Okay, nice to see you guys. Hopefully a nicer session today. All right, not too heavy. So what the plan is today is we'll start off looking at indices. So we sort of left it indices sort of halfway through a couple of examples. Okay, it was getting quite late. Okay, so we sort of stopped there. So I'll revisit the rules, okay, revisit some of the examples, and then we'll finish off sort of indices. Now, indices are important because it grows it back into algebraic sort of fractions and how we tidy up fractions. Okay, so this is one part of what I was saying, where we start to look round and back to something that we've already done. Okay, so that's why I said a couple of times that if you didn't get factorising at the start, you do revisit it. Okay, so don't worry if we don't get it at the start in the first week or so, first couple of months. Okay, we revisit it a couple of times. Okay, and today is one of these times. Okay, so we're using indices to sort of start going back into that because it's important to know those rules. It's important to know how we sort of deal with bad lighting. No, I'm not sure. Sorry, I got distracted there. How we deal with tidying up the powers. Okay, so let's sort of go through a couple of rules we looked at last week. Okay, we started combining those rules. Okay, and that's sort of where I left it. All right, when we started combining those and pushing it a wee bit. Okay, so first rule we sort of looked at. In fact, sorry, I'm getting ahead of myself. Is there any questions from last week? So I had a couple of emails, which is fantastic. Okay, sorry, I was a bit late in replying to some of quite a busy Wednesday, Thursday, but thanks for those emails. If you do have any issues through the week and you're trying out a couple of different resources, okay, please get in contact and ask those questions, and I'll try and come back as soon as possible. Okay. If we're happy, we'll push on. Okay, super. Okay, so just a quick one first off. Wee reminder of what I'll be looking at resource-wise. I just opened Moodle, don't know why that's closed. Sorry, it's locked me out. Okay, so just to show you where I sort of build up the class from, build the structure of the class, and where you can find more resources, okay? If it doesn't chuck me out. Super. Sure. Okay, so National 5 maths, guys, so you still have access to this. Any issues, give me a shout. Okay, so I like Dynamic 5 notes, remember? Okay, so have a wee look in that. That's a good wee resource. And the questions I use in class come from this booklet. Okay, so whenever I say question 3 from page 39, okay, it's from this booklet. Okay, so we're still working on the first unit, EF. Okay. Couple of different resources you've got access to, okay, and that sort of continues on. Okay, I also like just picking out what they do in bite size for the simple fact it's such a popular resource. Okay, so I'll sometimes touch on that. Okay, so tonight we are back into sort of algebra, okay, and we'll revisit the simplifying algebraic functions, fractions, not functions, okay, with a wee bit of the simplifying expressions using laws of indices. Okay, we're starting to build a couple together. Okay, so simplifying expressions using law of indices. Okay, and then simplifying algebraic fractions. That's all what we're building on tonight. Okay, just before, so I don't forget why we're in here. Okay, next week we'll go forward from algebraic fractions to applying the 4 operations to algebraic fractions. Now that sounds harder than it, that sounds harder than it is. Okay, all that is just adding fractions, taking away fractions, multiplying, dividing. Now we'll be doing it with algebra, okay, but if you can go back over working with fractions, which is in here, okay, if you want a wee bit more on that, working with fractions, so there's a wee bit in the Nat 5 pages, okay, but revisit Nat 4. Okay, guys, and that's for next week. So we might touch on that towards the end, but as I say, after 8 o'clock, we're starting to get tired and we might not pick up too much, okay? So just take a wee note for next week. If you can just look at the rules. So I don't want you to start applying it. I don't want you to look at working with algebraic fractions and start multiplying and dividing, okay? But if you look at just using normal fractions in those rules that apply, okay, from the Nat 4 notes, okay, and that will give us a really good standing when we start next week, okay? So, as I said, this week we will be finishing off the expressions using laws of indices, and we will be doing simplifying algebraic fractions, okay? And then sort of just building in. Okay, so fantastic. Resources wise, let's get right into it. Okay, superb. So when I'm saying indices, guys, I'm just meaning the power of. Okay, so when we see like a square sign is the most obvious. Okay, yellow. Okay, so something like 2 squared. Okay, we should be pretty familiar with, and that just equals 4. Okay, we can also get sort of algebraic expressions, so we can get things like x squared. Okay, and you know we can start adding like terms, okay, and taking away like terms. Okay, so if I had 3x squared plus 4x squared, okay, that would give me 7x squared. Okay, so we know we can start looking at like terms. What we started doing last week was bringing in some rules, looking at these powers, okay, and what happens to them when we start multiplying them out, okay, when we start dividing them, what that actually means, okay, in relation to those wee numbers that we see, okay, in the superscript position. Okay, so the first sort of rule we ran with, nice easy one last week, okay. If we've got a number to a power, okay, so remember these letters are just a wee space where a number can go, okay, multiplied by another letter, it's another power, okay. What that allows us to do is just add those powers together, okay. In the examples, started off quite nicely, okay, doing x times 3, oh, okay, these are from last week, guys, so you don't need to copy these down, okay, and wait, so I should have written that out fully. Okay, x 3 plus 5, okay, which equals x to the 8, okay. Threw some numbers in front of them, okay, it doesn't change. 2 squared times 4. Okay, so the 7 and the 4 multiply together, and the 8 and the 2 add together. Okay, so we started looking at them and we're working with indices. Okay, that's the multiplication rules. Rule 2 we looked at. Okay, was the dividing. Okay, so similar format to I did above. Okay, we've got xm and xn. Okay, we can write it like the powers are taking away from each other. Okay, and that's quite an important one for what we're going to do tonight and what we're working with tonight. We do quite a lot of sort of fractions with algebraic terms in the top and the bottom. Okay, so quite an important one going forward for simplifying things. Okay. Where'd my pen go? Okay, so a couple of simple examples of that. We've got y10, pardon me, divided by y7. we can write that as 10 minus 7. Okay, so the bottom number becomes a negative. Okay, and we'll look at that in a wee bit, and we'll think about that in a wee bit. Okay, and that just becomes y to the 3. Okay, so that's an important concept that we can get to the power of 1, we can get to the power of 0, and we can get negative powers as well. Okay, so let's think about all of these individual. Okay, so you can get positive powers. Okay, and these are the ones we're used to. Okay, positive powers like squared, cubed, to the power of 4, etc. Okay. Oh. But like this rule, okay, this n, if we bring it up into the top line, becomes a negative. Okay, and we'll revisit that. So we did a couple of them. We put some numbers in front of them. Okay, so we had 4x to the 7 over 2x to the 6. Okay, we can simplify those front numbers. Okay, and again, if you're not comfortable with fractions, with just numbers, how we do that and how we simplify that, please revisit that. Okay, it's a really important one, especially for next week. Okay, that we're comfortable with that. Okay, so if we ignore the x terms right now, and we just simplify the 4 over 2, that just simply becomes 2. And then we deal with the x terms, and it's 7 minus 6. Okay, again, that bottom term becomes a negative, okay, when we move it up. Okay, and we tidy that up, and we get to the power of 1. Pardon me. Okay, so that's really where we got to. We started combining this. I gave you a few examples to try.
Sorry, Daniel, can I just interrupt there a minute? Sorry. So you actually put 1.
Oh, sorry, no. So yeah, we would leave it like that. So in algebra, you don't really use ones, which is
right.
Okay.
Thank you.
So yeah, so 2x, so just having an x there means to the power of 1. So when you ever see that, okay, so if you had any x term, just single x term with no power, that's what that means. Okay, because to the power of 0 means something very different. Okay, and we'll explore that as well. Okay, so started combining them towards the end of last week's class, and that's sort of where we left it. Okay, so give you a couple ones to work through. Example. Okay. That is not a number. X to the 6 multiplied by x to the 2. Okay, divided by x to the 5. Okay. So that looks like a lot of sort of letters and multiplication signs in there and dividing signs. Like I say a lot of the times, just take it step by step. Okay, just take it one process at a time. Okay, again, this will become really important later on. Let's deal with the top first. Okay, what happens in the top, and then let's bring in what happened at the bottom and simplify that. So what's happening at the top? You can multiply those two, and the powers just add together. Okay, so in the top, we're just getting the x8, and we've got x5 in the bottom. Okay, so we've just added that 6 and that 2 to get x8. Then we're simplifying it by 8 minus 5. Okay, and the final answer is 8 cubed. 8 cubed. X cubed. Okay. Let's throw another one in there. 9 to 12. Okay, so remember that letter doesn't matter. What that letter is doesn't matter in algebra. Okay, so top line first, 12 plus 4, so you've got y to the 16, y to the 9. Okay, so just take it step by step. Then you'd be 16 minus 9, get y to the 7. Okay, So you're just applying those same rules. Okay, just the fact we're putting more to it. Okay, shouldn't fear that. Okay, you shouldn't worry about that. We tickly cough, so I just took a lap flow. Not entirely sure why for this class, but okay, so talking to myself is a good sign. Right, let's throw some numbers in front of the letters just to make that wee bit added complication. Okay, again, let's deal with the top first. Okay, and then bring in the bottom. So if we're dealing with that top first, okay, let's deal with the two numbers first. So the 4 and the 3, they multiply together. Okay, so 4 and the 3 will multiply together. X term comes in, then it's 6 plus 7. Okay. We've not done anything with that bottom term. Okay, so again, let's deal with the numbers first. So we've got 12 over 6. Okay, so we can simplify that down. Okay, both on the 6 times table. 6 goes into 12 twice. Okay, and it goes into 6 once, obviously. Okay, so x 13. Okay, so again, one step at a time. So we've tidied up the numbers there. Okay, remember I've not written it out, but essentially there's a 1 there. Okay. And then we deal with the x's. Okay, so just step by step. Don't be lazy at this point, just keep doing step by step, writing out everything. 2x, and it's 13 minus 3, 2x to the 10. Okay. One more example and then we'll move on to another Indus rule. Okay, everyone got that okay? Okay, so another example. Just making sure. Okay, so step by step again, guys. Let's do the top row. Okay, deal with the numbers first. So that will give you 20, 10 times 2. Okay, deal with the x terms. Okay, so it'll be 4 plus 7. Okay, so that's 20x to the power 11. Okay, and at this stage, let's just one step at a time. Okay, second step we deal with the bottom. So it's 4x multiplied by x to the power of 8. Okay, so remember there's essentially a 1 in front of that x to the power of 8. Okay, so it's 4 times 1. Okay, just gives you the number 4. Okay, x, remember there's essentially a power to 1 there, power of 1 there. Okay, now we don't write it in algebra, but that's what we're thinking. So there's an x to the power of 1, so it's 1 plus 8. Okay, so that gives you 4x to the power of 9. Okay. Okay, so we don't write that 1, but that's what's there. Okay, like we don't write in algebra 1 in front of that x. Okay, but it is there. Okay, And then it's a case of just simplifying that through. So let's simplify the numbers. Okay, 20 and 4, okay, both in the 4 times table. Okay, obviously 1 goes into the bottom, 5 goes into the top. So 5 x to 11, okay, over x to 9. Okay, that 4 becomes a 1. Because it's algebra, we just let it disappear. And then we deal with the x terms. Okay, so dividing, so it's just 11 take away 9. Okay, 5x squared. Okay, we're going quite fast, but this is sort of where we ended up last week, so I didn't want to take too much time going over it. Okay, is everyone sort of comfortable with that? Okay. On the face of it, quite simple, but the questions can throw you a wee bit. Okay, it's all about just repetition and just going through it, which unfortunately that's the case with a lot of maths, okay, and engineering. It's just repetition. Once you get comfortable, sometimes one of those days just clicks, okay, and it just comes together for you. Okay, so 5x squared, let's leave it there. So rule 3, and it's very similar to rule 1, okay, so rule 3, it's just a different way of writing out. Okay. Rule 3 of indices. Okay. If we've got a bracket, x, and there's a power in the bracket, okay. You can also have a power out the bracket. Okay. Remember, we'll do examples, so this will make sense in a minute. What that means, or if we were to break those brackets, okay, and if we were to start breaking the brackets up, which we do often, okay, it would be m times n. Okay, so if we've got a power inside the bracket and we've got a power outside the bracket, they multiply together. Okay, so let's look at that with some numbers. If we've got x cubed to the power of 5, okay, we can break that bracket up and say it's 3 times 5, x to the power of 15. Okay, so that would be lovely as an exam question. Okay, obviously we'll try and trick you. Okay, so let's do example 2. Let's throw a number in front of it. So we have 3x to the 4, and we're going to square that. Okay, so what we're thinking here. Now we've just learned the rule that we multiply the powers, okay? But we also have to do the same to the number in front of it. So in this case, we're also squaring the front number, okay? So we can essentially break that up into 3 squared multiplied by x, 4 times 2. Okay, and that's quite a messy way of writing it, and you probably, once you've done a couple of them, I wouldn't expect you to write it like that. That doesn't look particularly pretty, but that's essentially what we're doing. Okay, so we're squaring that front number, we're taking that power and we're doing the same thing to the first term and then the second term. Okay, so that number squared, 3 squared is just 3 times 3. Okay, it's 9, and it's x, x, and it's 4 times 2, so x is to the power of 8. Okay. Everyone see that, because we're starting to throw a wee bit more at it. Okay. let's do 2x to the 4. Okay. So you would be expected to know things like 2 cubed. Okay. And remember, when we're doing powers, 2 cubed is just equal to 2 times 2 times 2. Okay, we're just doing that 3 times. Okay, so you should be okay with it, but sometimes catches you out, especially if they throw another one, if it's 2 to the power of 4. Okay, if it's 2 to the power of 4, just add another times 2 onto it. Okay, so 2 times 2 times 2 is 8. Okay, so 2 cubed. So you'd be expected to be able to do that. So going back to 2 cubed multiplied by x to 4, and that 4 is multiplied by that 3. So we're taking that to the power of 3 and we're applying it to both terms in that expression. Okay, so we've already worked out 2 cubed is 8. It's x, 4 times 3 is 12. Oh. Okay. Okay. Let's throw something at you that it's quite rare to come up, but it is, unfortunately, it can come up. So we'll just use it. Okay, so 4x to the power of 7, y to the power of 3, and we'll put that in a bracket. Tidy up that 3. Okay, and then we'll square that. Okay, so we've got 4x to the power of 7, y to the power of 3. Now the important thing to note here is they're all multiplied. Okay, so it's 4 times x to the power of 7 times y to the power of 3. Okay. Nothing changes in our approach to this. Okay, so we take each part of that expression and we apply the square to it. Okay, so it's going to be 4 squared multiplied by x to the power of 7 squared, y to the power of 3 squared. Okay, so we can write it out. Okay, let's tidy that up. Okay, so nothing changes, we're just putting another letter in there. Okay, so again, don't be put off by that. Oh, 4 squared is not 4. My word. What am I doing? What am I doing? 4 squared is 4 times 4, which is 60. Sorry. Sorry. Okay, so that's an important one, breaking the brackets. Okay, so that will help us later on. Then again, we go back into bringing that factorization back into it. Okay, want you to try a couple? Oh, my writing is quite wild tonight. Okay, that last one in there is just a wee toughie. All right. So that's 25-2. So 5 questions, 2 minutes each, say. Should be enough time. So come back on at 1:45. Okay, come back together at 1:45. Okay, so 9x to the power of 10. Why is that not sharing? That stopped sharing for some reason. Sorry, making up. Okay, 9x to the power of 10. And that would be times. Okay, and then we just apply the rule number 1. Okay, so 4 times 9 is 36. X to the power of 10, x to the power of 8 would be x to the 18. Okay, so just threw 2 rules in there at you. Okay, so hopefully you picked that up. Okay. Okay.
Just a wee question, please. See, in terms of some of the ones you need, like, see they're cubed or squared, how would you know? Like, see, like the first bit of working. Sorry, does that make sense?
So what, these ones?
Yeah. So say for example, obviously that 5 there in the third one, right? You're obviously cubing that. How do you know the first thing to do is cube? Like cube the number.
So cubing this one. So you're applying it to both. So that 3 you treat separately to that x to the power of 7 when you're bringing in the power outside the bracket. Okay. Similarly, when we're sort of pardon me, multiplying things together. Okay, we do the numbers. We do the numbers first. Okay, so it's 9 times 4, and then we take the like terms, so the x and the x. Okay, and then we do that. Okay, so how would you know to cube this first? I think what you're looking for is when these terms are multiplied together. Okay, you can treat them effectively separately. Okay, so dividing numbers, okay, there's a number in the x term on the top line and a number in the x term on the bottom. We treat the numbers first, and then we treat the x's. Likewise, when we multiply down here, likewise when we're cubing and squaring. Okay, so when it's if it's a multiplication here, so it's 3, effectively that's saying 3 times x to the power of 7. Okay, but we don't write that out fully, but it's separate terms. Okay, so we treat that 3 first with that cube term, and then we treat this x to the 7 with this cube term. Now we will do this later on, so it's actually a really good question, and this is why I'm trying to explain it without covering that stuff. Okay, what might be confusing you is we could throw an add in there. Okay, and that's sort of probably what we're more used to when we were doing sort of expressions, when we were doing factorizing. Okay, so don't write this down. Okay, so you might be more used to like that, and you're seeing like this add, and you know to treat them separately. Okay, so I get that this looks a wee bit more, I wouldn't say confusing, but a wee bit more messy about how to deal with that. So hopefully we're building up to things like this, and it might make more sense. Hopefully it does, about how to sort of treat each of these individual terms. Okay, and when you treat them separately and when you treat them together. I think, yeah, hopefully. So I don't think that was a great explanation, but hopefully it's just a wee bit clearer there. All right, and hopefully it just comes down to practice. But do you see where the answers come from? Like, so this term you're looking at where it's cubed, do you see where the 27 and the x to 21 comes from?
Yeah, I get it overall. I think I just made a mistake, whereas some of them needed to be cubed. I was squaring them at the start, so then obviously
right. Yeah, that's just my writing then.
I think that's wrong, but yeah, I understand.
Blame me. Nice one. I'll sort that out. Okay, so what have we got? A couple more rules, and then we'll tidy that up, and then we'll take a wee break. All right. So again, we combined a rule there. Okay, so let's do a couple more examples of that. Hopefully it sort of clarifies what I was trying to say there. Okay, so I'm still in red. Okay. 2y equals 6. -14. Okay. So again, we treat the top line first. Okay, just take step by step by step, and don't feel like you're doing something wrong if you need to write out, multiple lines. Okay, but just take it at your own speed. So I'll do the top line first. 2 cubed. Okay, we're just doing 8y, and it's 6 times 3, 18. Okay, we're over 5y, 14. Okay, we're tidying up the numbers first. Okay, so they're both in the 4 times table. 2 of them on the top, 1 of them on the bottom. Okay, but we don't write the 1 at the bottom. Then the y's we tidy up. Okay, we don't need that. 18 minus 14. Okay. Get there. Okay. So again, just combining rules, so there's nothing we've not learned at or looked at. Okay.
Daniel, 3 times 2 is 6, not 8.
It's cubed. So it's 2 times 2 times 2, remember? So let's, oops. So remember the rule here will be 2 cubed and then y 6 to the power of 6 cubed. Okay. Super. Okay. Let's just run it. Okay, so and I could have written that as 2 big fingers today. Okay. And then you get your 8 from that. Okay. Super. Okay, let's throw out a pretty outrageous one. X squared to the 6. By all accounts, that's quite a ridiculous one, but there's no reason why something like that couldn't come up. Okay, again, just take it step by step, take one at a time. Okay, and just work through your processes. Okay, so let's just take this here. Okay, if we had that on its own, what would we do with it? Okay, so the 3 would be squared. Okay, it would make 9. Your x squared would be multiplied by 2, so it would be 2 times 2. And your y to the 6 would be times 2 as well. Okay. Just write the rest as normal. Just tidy that up. Okay, so 3 squared is 9. X 2 times 2, so x to the power of 4. Y 6 times 2 to the power of 12. Multiplied by 4x to 6. Okay. So remember, don't rush and don't jump ahead too far. Okay. Okay, so again, now we just deal with the top line. Okay, so we've dealt with the bracket, we've broken out that bracket. Now deal with the top line. Okay. That 4 and that 9, we're just multiplying together. Okay, that x term and that x term, we're using rule number 1. Okay, so it's x to the power of 4 multiplied by x to the power of 6. So it's 4 plus 6, which gives x to the power of 10. Okay, nothing's happening to the y. Simplifying 36 and 24. Okay, and you might take a few goes to simplify this, okay, because they're in quite a lot of multiplication tables. So they're in the 2 times table, they're in the 4 times table, they're in the 6 times table, they're in the 8 times table. They're also the highest times table they're in is a 12. Okay, so you might have to simplify that twice, okay, if you pick the wrong multiple. Okay, so 36 and 24 are both in the 12 times table. So it goes 3 times into 36, and it goes in twice to 24. Okay, the x, 10 over x to the power of 6 is just 10 minus 6. Okay, so it's x to the power of 4 on the top line. Okay, and then the y powers, okay, there's more in the bottom. Y to the power of 3 in the bottom there. Okay. So what I just did there is quite important. Okay. In fact, it's so important we can write it as its own rule. Okay. So we had y12 over y15. Okay. So that's y12 minus y15. So essentially we could have written the minus 3. Okay, but we put it straight onto the bottom line. Okay, that is because we can write indices. Okay, so this brings us nicely to rule 5. Rule 4, which states if we've got a negative power, then we can write that as 1 over. Okay, so if we're left with a negative, okay, we can essentially put that in the bottom line. Okay, let's do a couple of examples of that so you're not too thrown off. Okay, so if we end up with something like x to the minus 4, we can write that like that. Okay, so that's essentially what we ended up with. We ended up with the y. If we'd kept it in the top line, would have been negative 3. So we can move that down into the bottom. Okay. Likewise, if we had y to the minus 6, what have you seen something like x squared divided by x to the minus 4? Okay, so we can simplify that in 2 ways. We can write that in 2 ways. Okay, so we can simplify that by saying x squared minus 4, okay, which gives us x to the minus 2, and then use the rule to go 1 over x squared. Now, you might see that exact same expression. Okay, that could be given you in the format x squared multiplied by 1 over x to the 4. Okay, all that is the same. Okay, x squared times 1 over x to the power of 4, okay, is the exact same as that. Okay, so if we go through that, okay, okay, so we end up at the same answer. Okay, so it's just two different ways that you could see that written. Okay, so just be careful. Okay. We will see these used in sort of bigger equations, so these are probably in its most simple form, but that's sometimes the most confusing way to look at it. So when we do more difficult examples, when you come back to it, it will click into place. Okay, so don't look at that straight away and again completely discount it. Relax, digest it, we'll do a couple more examples, we'll come back to it and it might make sense. Okay. What happens if we end up with the power of 0? Okay, and I accidentally put this on 2 weeks ago, oh sorry, 1 week ago, and we've seen that happen. Okay, so we can feasibly write an equation like x squared divided by x squared. Okay, that's just x 2 minus 2, if we're following the rule. Okay, dividing powers, so it's just minus in the top. And that gives us 2 minus 2 is 0, so that will give us x to the power of 0. If we ever get to the power of something, to the power of 0 or something, okay, the answer is 1. Now, that makes sense. Okay, if you look at x squared divided by x squared, it's the same as if you had 4 divided by 4, or 2 divided by 2, or if you had a number divided by the exact same number, you would end up with 1. Okay, so if you do that with powers, okay, x squared divided by x squared, okay, you're going to end up with the number 1. Okay, so if you work through an equation and you're trying to simplify it down, okay, and you're working through an expression, and if you end up with to the power of 0, that becomes the number 1. Okay, and then the letter in that case, in this case x, will disappear. Okay, if we were to throw some numbers in with that, okay, just to add a wee bit more to it. Okay, so say we had 4x cubed over 2x cubed. Okay, following the rules that we've been working to, the dividing indices rule, okay, the numbers would simplify to the number 2. Okay, so 4 divided by 2 is 2. And then the x terms would be 3 minus 3. Okay, so 2x to the 0. That x to the 0 just becomes the number 1. Okay, therefore it's just 2. That there, we substitute in the number 1. So if we substituted in that number 1, it would just be 2 multiplied by 1. That's what that's telling us there, which gives us 2. Okay, so the 1 looks like it disappears, or the x looks like it disappears, but it essentially becomes the number 1. 2 times 1 is 2. Okay. We have to put in a slightly more complex one and combine a few rules. Okay. 10x squared y. Okay, so 10 over 5 becomes 2. X squared is x to the power of 2 minus 2, which is x to the power of 0. Okay, and y, okay, this here, remember we don't write it, but that's effectively y to the power of 1. Okay, and then you're taking away this 3. Okay, so it's okay. So simplifying that even further, we leave that 2 as is. That x to the 0 becomes a 1. And that y to the minus 2 becomes 1 over y squared. Okay. Tidying that up, final answer would be 2y squared. You will be delighted to know that's all the rules. Alright. So you'll be delighted to know that is all the rules that you need to know. Okay, it's just a case of practice. Looks confusing, but if you take it step by step, it makes sense. Okay, things like tidying up this, so it's 2 times 1 times 1 over y squared. Okay, we'll continue. We're looking at fractions next week, remember? Okay, and I've asked you to look at sort of nat 4 fractions just to make sure you're on top of that, and there's a wee bit in nat 5 as well that just refresh yourself with. So when you're looking at that, that might become more apparent. Okay, when you look through that. Okay, so we might be jumping ahead a wee bit. I've written this out, okay, and it's just a wee reminder. So when I sometimes, if I get stuck or if I want to double check that I'm doing things correctly, I sometimes make a really simple example of it and do it in my head and then apply it to whatever that more complex sum or more complex equation, expression, whatever that may be. Okay, so the best way to go through in your head, if you're doing the powers correctly, if you're doing things like to the negative of, is just use the most basic, and that's using it all with the number 2. So I've written out on just a wee sheet of paper, just a wee reminder of what everything means. Okay, so I'd sort of expect you to know 2 to the power of 4 is 2 to the power of 3, 2 squared, 2 to the power of 1, 2 to the power of okay, so if we just write everything out in full there, and just make sure that we can apply that to sort of numbers. Okay, so 2 to the power of 4, all we're doing there, 2 times 2 times 2 times 2. Okay, so 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, so if I know that and I see something to the power of 4, I just make sure that, right, that's how many multiplications I've done. It's just a really simple example I keep in my head, okay, that I can double check and then apply it to a more complex thing. So if I see something to the power of 4, I go, right, that's what that means, and then sort of work backwards from there. It's just something I do with quite a lot of different equations. So if I have a more basic example in my head, I can apply that, all right? Doesn't work for everyone, but Okay. So if I see something to the power of -4, if I know a really basic example in my head, I can apply it and then sort of work backwards and sort of fill in the gaps. I do it with more complex expressions as well, and it helps me. So it's there. Okay, guys, let's take a break because that's the sort of end of indices. Oh, comment. Yes. Yep. Reciprocal. Did I say that? No. Okay. So yes, Amber. Okay. Nice one. Okay, let's take a break, guys. Been going through quite a few examples. Let's take 20 minutes. So say we come back at 35 past. Okay, so we'll let the dog out, get a juice, get a wee bit of fresh air. Take 20 minutes. We'll come back at 7:35. Okay. Pardon me. Okay, on page 30 of that E&F workbook, okay, it's got those simplification of fractions through the cancellation process. Okay. So the cancellation process we do when we just see a multiple. Okay, and that sort of question came up of how do you know when we apply powers and how do we know when to cancel and things like that, and how to deal with these numbers. Okay, so that should give you a good go at that. Okay, so if you work through some of them, remember the answers at the back. It should allow you to pick up. Okay, so what this is sort of building into is sort of combining what we did with factorisation and looking at simplifying fractions in a slightly different way. Okay, so we're going to look through or bring back our sort of rules of factorisation. Okay, so we're going to sort of circle back into that, which will be quite good for us. Okay, and simplify fractions using things like common factors, and then simplifying the numerator and denominator, which is the top and bottom line, by going through our CDT process. Okay, so that CDT process that I spoke so much about when we're doing it. Okay, that sort of idea. So we'll work through some of those just to get us back into that frame of mind about factorisation. So hopefully we shouldn't take too long doing this. Okay, I'll let you work through some examples, and then we should hopefully finish about sort of 8:30ish. Okay, and then we'll really crack on with it next week and start that afresh. Okay, so through cancellation, we've looked at, that's all about indices, working with that. Now we're going to look at using our CDT terms to simplify as far as possible the fraction. Okay, so what do I mean by that? When we get a fraction which has something like that, okay, what you're looking out for is a plus or a negative sign. Okay, if we've got a plus or a negative sign here, we know we can't simplify through cancellation. Okay, and when I say through cancellation, what we've been doing tonight, the first half of tonight. Okay, so we can't simplify that straight away. We can't simplify that 8 and the 6 straight away because we need to deal with this addition. Okay, and this is where our CDT process comes in. So if we just have a wee reminder of what the CDT process is. Okay, it's when we've got algebraic expressions. Okay, we're looking to simplify with common factor. If there's no common factors, we move on. Is it a difference of two squares? Okay, it's not a difference of two squares. Okay, is it a trinomial? Okay, so we're back to this. Okay, so we're doing fractions like we've been doing, okay, but we're having to build in this idea of factorization to simplify down to then use cancellation. Okay, so we're building on what we took with factorization, we're building on the index idea, we're bringing them both together, and we're sort of, going through examples like that. So this is where you'll probably see it. This is how it'll probably look in the exam. Okay, you get a factorization question, okay, but you probably get a simplification of a fraction as well. Okay, so these two questions are really common. Okay, just how complex they throw it at you is up for debate. Okay, so let's look at it. Let's go through it. Okay, so if we were looking at this, okay, we see that symbol or a negative sign, okay, that immediately tells us we need to do CDT on that top line. Okay, we need to look if it's got a common factor, if it's a difference of two squares. Okay, and don't worry if you've forgotten what difference of two squares, we'll go back over it. And is it a trinomial? Okay, so looking at that straight off the bat, does the expression AA plus 2, okay, which is an algebraic expression, there's a letter in there, so it's an algebraic expression, does that have a common factor that we can remove? Okay, the answer is yes. Okay, the number 2 goes into AA and the number 2 goes into 2. Okay, so just looking at that top line, and this is very important, we're not looking at the bottom line, we're treating each line separately. So we're dealing with the numerator, okay, which is the top line, and we'll deal with the denominator completely separately. The denominator is the bottom line. Okay, so dealing with the top line, does it have a common factor? The answer is yes. Okay. Now we've got two terms that multiply together. We can use cancellation to simplify that. Okay, so we've got this 2 multiplied by this expression. Okay, so this is where brackets are important. Okay, so we've got that number 2 multiplied by that bracket. Okay, so we've taken that 2 out as a common factor to simplify it, but now as it's a multiple, we can simplify that, pardon me, that further. Okay, and the 2 and the 6 simplifies down to a third. Okay, in algebra, we don't write out that number 1. Okay, so we would leave that expression simplified like that. Okay, so that's as simple as that expression can be. So when you see a plus sign or a negative sign on the top or bottom line, immediately go to CDT. Okay, algebraic expression with a plus or a negative, CDT. Okay, so let's go through a wee bit more of a complex one. Okay, so example 2, we've got 3b squared. Okay, and don't be put off that the letters changed. Okay, so we've got quite a lot going on there. Okay, again, math, take it one step at a time. So we want to deal with the top line and the bottom line separately. Both the top line would carry out a CDT process, and the bottom line we simplify using the CDT process as well. Okay, so using the top line, just take it to one side. right top, okay, and then just deal with it. So 3b squared plus 12b. We want to carry out c, d, t. Okay, so it's an algebraic expression. Is there a common factor? Okay, so there is. Okay, so that's it. That's all we need to do. We don't need to bother with the d and the t. Okay, we don't need to question it. We've found common factors, so let's look at it. Pulling a common factor out of that. 3b. Okay, so how many 3b is going to be squared? Okay, 3b is going to 12b. Okay, so the common factor there is 3b. Okay, 3b can be used and multiplied by b plus 4 to get that expression. Okay, so that's us dealt with the top line. We've still got a bottom line to deal with. Okay. In fact, remember just to look at that, make sure it's simplified as far as we can. Okay, in this case it is, so we don't need to worry. Okay, so we need to worry about this bottom line. Okay, so let's remove that. Okay, so the bottom. Okay, 5b squared plus 20b c e t. Is there a common factor? Yes. Okay, pardon me. Okay, 5b multiplied by b plus 4. Okay, so we've got a simplified term that we can use in the top line. We've got a simplified term we can use in the bottom line. So put it back together. Put both the simplified terms back together. Okay, it turns into 3b b plus 4 over 5b b plus 4. Okay, so I'm hoping you see that we now have a multiple. Okay, so we can use cancellation to remove that b plus 4 bracket. So that b plus 4 bracket is a term that we can cancel out with the b plus 4 at the bottom line as well. Okay, so we cancel that, we cancel that. Okay. Now, is that in the most simple expression? Okay, the answer is no. Okay, so remember we can look at the b's. Remember that's b to the power of 1, b to the power of 1. Okay, so if we use a rule that we looked at earlier, okay, so b to the power of 1 minus 1, okay, we can cancel those b's out as well and just get 3 over 5. So those b's actually cancel each other out. Okay, so that term we started with, that whole term, so 3b squared plus 12b over 5b squared plus 20b can simplify right down to 3 over 5. Okay, but you have to simplify the top and bottom line to allow you to do that. Okay. Let's look at another example. So I've got four x squared minus 16x over okay. Immediately I want you to pick up these. Okay. Immediately you're looking at that and saying we can't use cancellation at this point because there's negative signs there. Okay, so we can't cancel anything out. So we can't take this expression and cancel it down into its simplest form. Okay, because we have to deal with this. Okay. So we need to use CDT and CDT. The common factor is always first. Okay, so don't try and jump into difference in two squares. I say that because 4x squared minus 16x looks like a difference of two squares, but it's not. Okay, so that x means it's not. Okay, but 4x squared minus 16. Okay, so always work through in order. Common factor, differences two squares, trinomials. So working with the top line only. What's the common factor? Common factor is 4x. Okay. Working with the bottom only. What's the common factor? The common factor is 3x. Okay. Remember, bring these back both together. Okay, so your top term and your bottom term. Pardon me. Okay, now we've got, oh, sorry, someone just joined us. Connecting. Hi, Holly. Okay, so we've got two multiples now. Okay, because we've removed that sign, we've got multiples we can now cancel out. So we can cancel out top bracket with bottom bracket. Okay, leaving us with 4x over 3x. Okay, next step would be x and x cancel each other out. So the simplest that could be is 4 over 3. Okay. Okay, so let's have a wee bash, and the clue's there. We're using the common factor, but just write out CDT just to get good habits, and then tick off common factor. Okay, so these ones are obviously going to be all common factor. Okay, so so let's take 10 minutes just to try a couple of these. Okay, take 10 minutes and try and work through 3 of these. Okay. Just pick 3 random ones. Okay, so take 10 minutes and work through 3 of them. Okay, so we'll come back at 8:05 together. Okay, and look at that. Okay, any questions? I'll be at the desk, so if you want to just shout out or put something in the chat. Okay, so yeah, I thought I'd pick up on question E. So page 30, question 2. Okay, and it's question E. And E is asking xy plus x squared. Okay, 6x plus xy. Okay, oops. So, a lot going on here, and you see xy and xy. What we should be aware now is that if there's a plus on the top or the bottom, we can't cancel that out. Okay, so the first step, we cannot cancel that out. If there's a plus sign on top of the bottom, we need to do CDT to try and simplify that down. Okay. Taking out, pardon me, taking out common factors, x.
Daniel, sorry. It's still on the question sheet, sorry.
I think I'll be good at it. Okay, let's start again. Okay, question E, xy plus x squared. Perfect, thank you. Okay, over 6x plus xy. So top, let's carry out CDT. Okay, is there a common factor? Yes, we knew that already. Okay, x, y plus x. Okay, bottom one, same applies. Okay, is there a common factor? Yes. Okay, so we divide that. Again, x comes out. Okay, now the examples I did just before I asked you to go and do some questions, we always cancelled out the brackets. Okay, that doesn't necessarily have to be the case. We can cancel out whatever's happening outside the brackets as well. So in this case, there's two x's. There's no numbers or there's no nothing else. Okay, there's two x terms, and we can cancel them out. Okay, so that x term and that x term, we can cancel out. Okay, so we're left with whatever's in the brackets. Okay, we don't necessarily have to write the brackets. We can leave it like that. So that can't be simplified any further. Okay.
Daniel, see the two y's there. Is there any chance they would be simplified out? And if not, why?
Okay, so this sign, so we can't do cancellation when we've got addition. Okay, the only reason we can do it here is because we've put that addition in a bracket and it becomes a multiple of that term. In this
Right.
case, it's the x term. So essentially this line is x times that bracket.
Mhm.
Okay, if you were to write it out fully. Now we don't write the times sign, we just have that and then the bracket beside it. Okay, but that's indicating x times. Because it's a multiple, we can now cancel one of the multiples. So we could cancel that whole bracket if it was repeated. So like the questions we did just before the break. Okay, like here, where we cancelled that whole bracket. It's because that whole bracket was now multiplied by whatever outside it. Okay,
Right. Okay.
so we can't cancel these y's because of these signs. Okay, because it's being added to something else. Okay, and we can't simplify that expression any further. Okay, so if we got to that expression and it was a wee bit more complex, say, we could carry out CDT again to see if we could carry out any further simplification. So is there any common is there any common factor in that? No. Okay, so we can't remove any common factor. It's not a difference of two squares and it's not a trinomial, so we can't simplify that any further. Okay. Those three methods are how we simplify algebraic equations. Okay, so when you see letters and we're trying to simplify, those three letters. Okay, but only if the whole bracket is a multiple of something else. Okay, so losing my voice. I did M as well. Okay, so M was 14p plus 28p squared over 8 plus 16p. Okay, so looking at that first off, quite complex. Don't worry too much, okay? Look at the top line, do your CDT. Look at the bottom line and do CDT. Okay. Straight off the bat, common factor, absolutely. The highest in this case is going to be 14p. Okay, so 14p goes into that once, and it goes into that 2 times, like 2p. Okay, so yes, got a common factor. So I'll write top line is going to be 14p bracket 1 plus 2p. Okay. CDT in the bottom, is there a common factor? Yes, the number 8. Okay, so we can remove that number 8. Okay, and put that in the outside of the bracket. Okay, what you'll see is we've got the same bracket, which is good. Okay, so writing that out fully, the top term we've simplified down. Oops. Okay, first thing we can see there, that's now a multiple. Okay, so because we've got that expression in a bracket, we can take it as a sort of whole. Okay, and we can cancel out the top and the bottom brackets. Okay, so 1 plus 2p and the 1 plus 2p at the bottom cancel each other out. Okay. We get to 14p over 8. Ask ourselves, can that be simplified any further? Is there anything that goes into 14 and 8? Okay, the answer is yes, the number 2. So it goes in 7 times to the top line and 4 times in the bottom. So the simplest that expression could be is 7p over 4. Okay. So that was slightly different to what we did, just for the simple fact this p came out and there was no p at the bottom and we cancelled out. Okay, so not too bad. Okay. Super. Okay, so do a couple of examples this time with difference of 2 squares. Okay, and we'll go back over what difference of 2 squares means, etc. Okay, just again, that repetition is just good for us to have. Okay, so we'll do difference of two squares, then we'll do a couple of examples of trinomials, and then that's us calling it a night tonight. Okay, so hopefully another 20 or so minutes. Okay. Okay, so difference of 2 squares. So the d term and that's c dt. Okay, and difference of 2 square terms is when we've got an expression, a trinomial, we've got an expression, an algebraic expression, which has got a squared term as the first term. Okay, it's got a negative, and then it's got a squared term as its second term. Okay. Now, commonly see that as something like x squared minus a number. Okay, so we need to know our square numbers, remember? Okay, so 1, 4, 9, 16, 25, etc. Okay, we're often looking for that. Okay, but it's in this format. So remember, I'm just using letters here where a number could be. Okay, so x squared minus a squared number. So it's always got to be a negative though. It's the difference of 2 squares. So let's put an example of that in. So example 1, x squared minus 4 over x plus 2. Okay. That term there is a squared term, okay, and that's really obvious too because we see the power of 2. Okay, so we know that's a squared term. Okay. The negative sign is there, so we know it's a difference. That last one there, that number, the number 4, is a square number. Okay, so effectively that's just 2 squared. Okay, so the difference first, negative sign, and then a squared number. Okay, so that's the type of format we're looking for. Okay, so going through and let's simplify this down. So we get that expression saying simplify, simplify the fraction as far as possible. Okay, carry out CDT in that top line. Is there a common factor? No, there's no common factor except the number 1. Okay, so there's no common factor. Is it a difference of 2 squares? Yes, it is. Okay, 1 square number minus the second square number. Okay, bottom is an algebraic expression as well. Can we simplify that though? Okay, is there a common factor we can take out? No. Is there a difference of two squares? No, and it's not a trinomial either. So that's actually in its simplest form. So we don't need to do anything. Don't be put off with that if that gets given to you. Celebrate the small wins. Okay. What that gives you is a clue to what type of brackets you're looking for. So if you're simplifying it and you're factorising the top line, you'll probably end up with an x plus 2, so you can create a cancellation. Okay, so let's go for that. Top line, CDT, so we know it's a difference of two squares. Remember, the difference of two squares format is the first squared term, okay, without the square number, plus the second, first minus the second. Okay, so that the difference of two squares, when you factorise it, that's the format, that's a standard format. Okay, so the first square number plus second, brackets, first square number minus the second. Okay, the second line we don't need to simplify, so let's just put that straight in. Okay. So we've got a multiple up the top, and we've got the full expression down the bottom. Okay, so there's nothing else added on to that expression. So we can cancel that out. Okay, and that might throw you a wee bit for the simple fact that I said we need to have a multiple. If you think about what that bottom expression means, we could write it as 1 times x plus 2. Okay, but we don't write that 1 in algebra. Okay, so we could put that x plus 2 in a bracket, and that's why it can cancel out. Okay, so it might throw you a wee bit because I said you need to simplify it to create a multiplication, but if it's there sitting on its own, so if one of these brackets, in this case the x plus 2, is exactly the same as the expression on the bottom, then you can cancel that bottom line out. Okay, and that just leaves us with x minus 2. Okay, that just leaves us with this here. Okay, so if one of the brackets is the same as the expression down the bottom, we can do that. Okay. Okay, let's throw another one. Oh God. Out. Okay, so we've got 4a squared minus b squared. Okay, so a lot going on there. Nice and complicated, but work through it, the normal process. Okay, it's an algebraic expression. We can't do anything with cancellation. So the top term and the bottom term have that negative sign in it. Okay, they don't equal each other exactly. Okay, so we can't do anything with cancellation, so we have to do that CDT to simplify it down to try and get us an expression we can cancel out. Okay, so top expression first. Is there any common factors there? Okay, so no numbers or letters can be pulled out as a common factor. Okay. Is it a difference of two squares? Okay. Yes. Okay. So remember, the difference of two squares, the standard format is your first squared term plus your second squared term. Your second bracket will be first squared term minus your second squared term. So the first squared term there is 2a plus b, 2a minus b. If you were to break that bracket up, you would get 4a squared minus b squared. Okay. So that's standard format. Bottom, go through it, okay? Don't be caught out here, there is a common factor. Okay, so remove that common factor. Me. 2, then we've got 2a minus b. Okay, and then we bring it back together. Okay, so you could do that at the side, you could do it under if you've got different coloured pens. You can write the word top and then work everything out. Write the word bottom, work everything out. Whatever makes sense in your head, you can lay that page out as you want, okay? Just make it nice and obvious. Okay, top expression then. 2a plus b, 2a minus b. Okay, divided by. So top and bottom now we've got multiples, fantastic. Okay, there's a bracket on the top with 2a minus b and there's a bracket in the bottom with 2a minus b. They cancel each other out. Okay. Okay, so we can't simplify that any further. Okay. Don't rush and think, oh, there's a 2 there and a 2 there, and then simplify it down. That doesn't work because we've got this plus sign. Okay, so remember, you need to treat this expression in the top as a whole. Okay, so unless you can take out a common factor there, you can't simplify that down. Okay, so just be very careful with that. Okay, again, that's just a repetition thing, that's just a practice thing. Okay, knowing when you can and when you can't. Only when there's a multiple can we do cancellation. Okay, so examples of that, practice questions of that is question 3 on page 31. Okay, so top and bottom there. I'm not going to stop and do that. I'm going to just move on. Okay, so question 3 on page 31 will allow you to practice that. Okay, but I'll jump in. What a choke. Oh, I think this is good timing. I'm about to lose my voice. Okay, going to put in a couple with the last letter, so the trinomial ones. Okay, and just remind ourselves of how they can be simplified down, and then simplify a fraction as well. Okay, so let's have a look. Example. Okay, so we've got d squared minus 3d over d squared minus 2d minus 3. Okay, badly drawn 3. Okay. First thing we notice that we can't simplify with cancellation because it's an addition. Okay, so we can't do anything. Likewise, in the bottom, there's too many terms. We can't. So we need to simplify it first. So we need to go through our CDD process. No bother at all. Again, work top, then work the bottom, then bring it back together. Okay, so the top term, d squared minus 3d. Is there a common factor? Yes. Okay, so straight off the bat, we take d out as a common factor, and we get that. Nice and easy. The bottom. However, is there a common factor? No. Is there a difference of two squares? No. because there's 3 terms, it's a trinomial. There's an x squared term, oh sorry, there's a d squared term, there's a d, and then there's a number on its own. Okay, remember the letter doesn't matter. Okay, it's just there. So trinomial, I'll just write that out. D squared minus 2d minus 3. So remember the way we do this. When we're working with trinomials, we're looking for two numbers that multiply together to make that last term. Okay, so remember, multiply to make minus 3. Okay, and then they need to add together. Okay, to make minus 2. So multiply and add. Okay, so we set that up as a wee table over to the side. Okay, so completely move away from your expression over to the side. That minus 3 is coming from that last term. Okay, remember to be very careful with this sign. Remember to take that sign. Okay, so minus 3 in the multiply, minus 2 goes into the add. So we're looking for two numbers multiplied together to make minus 3. So these numbers have to be a plus and a minus, or a minus and a plus. Okay, because you can't get a negative number if you multiply two negatives, and you can't get a negative if you multiply two positives. So we need to have that combination. So good habit, just write that there so we know to do that. Okay, so what are the factors of 3? Nice and easy. Okay, we've got 1 and 3. We need to pick the correct signs that will give us negative 2. Okay, so what number is going to be negative here? Okay, negative 3. Okay, so let's put that into brackets. Again, if this doesn't ring a bell, go back to factorization. Just have a wee reminder. Okay, so that's that bottom term factorized using trinomials. Okay, so d plus 1, d minus 3. Okay, so let's bring them back together. 2 seconds. Okay, they'll just fell out. Nice one. Okay, so let's bring that back together. The top term we've now simplified down to d bracket d minus 3. And the bottom term we've simplified down to d plus 1, d minus 3. We've now got a multiple at the top and the bottom. Okay, so we can take that d minus 3 that's in the bracket and cancel that out. Lovely. Lovely. Okay, can we simplify that any further? No, because the expression at the bottom we can't simplify down any further. Okay, so that d plus 1, there's no common factor, there's no difference of two squares. Okay, there's no trinomial. Okay, so we can't simplify that expression down. We can't cancel out the d's, okay, because it's not a multiple in the bottom. Okay. Right, so 2 more examples, guys. Bear with me. Okay, 2 more examples, then we're done for the night. Okay, that should be an 8. Okay, so CDT. Perfect, lovely. Okay, so top. Is there a common factor? Yep, there is. Okay, so let's do that first. Okay, so remember, you can have multiple different things. Okay, so let's take out the common factor. 2, and that leaves us with x squared minus 16. Okay, Can that be simplified any further? Remember, we can simplify whatever's in that bracket, okay, by using that CDT. So we continue on with that CDT. So as soon as we pick out a common factor, we're not finished, okay? We continue on. Is that now a difference of 2 squared? The difference of 2 squares. Okay, so is the first term in the expression a square number, or is the second term? Yes. Okay, so it's also a difference of 2 squares. So remember, the number outside the bracket stays the same, and then we split the bracket up into the standard format, which is whatever the first term is squared plus the second term squared, new bracket, first term minus the second term. Okay, so that's that top line fully broken down, okay, and simplified. Second one, okay, you can tell what it's going to be, but just go through the process. There's no common factors. It's not a difference of 2 squares, but it is a trinomial. Okay, so that bottom one, okay, so we start with x squared plus 2x minus 8. Go over to the side. We want two numbers that add together to make positive 2 and multiply to make minus 8. Okay, so the numbers that we need to make minus 8 multiplying together, one has to be negative, one has to be positive. Okay, so positive, negative, negative, positive. So whatever two numbers we pick, one has to be negative, one has to be positive. Okay, and we're adding them together to make positive 2. Going through everything, all the factors, 1 and 8, 2 and 4, and that's it. So 3 doesn't, 4 does, 5. Okay, so that's all the factors. So we're looking at two numbers there that add together to make plus 2. Okay, it works if we make that negative and that a positive. Okay, so negative 2 and plus 4. Okay, so we can put that into brackets. Okay. And that's that term fully simplified down. Okay, so we've got our sort of factorized terms. Brilliant. Okay, so let's bring that back in. So the top term we've now put as 2x plus 4, x minus 4, all over x minus 2, x plus 4. Okay, so again, quite a lot going on there, but what we can see is there's two brackets, x plus 4 and an x plus 4 that can cancel out. Okay, we can bring that down, x minus 4. Okay, that can't simplify any further. We can't take that any further, so we can't simplify that x minus 4 and we can't simplify that x minus 2. Nothing else can be done to that. Okay. God, it's amazing where time goes. So much for an early night, yeah? One more example, guys. It's for this one. Okay. Sorry. So one more example, and it's a term, an expression with a trinomial that's got something in front of the x squared. Okay, so let's just go over what that process was. Okay, so 3x squared plus 5x minus 2. Okay, because remember, when you're working out a trinomial and there's something in front of the x squared, we need to take this into consideration and do what is, by all accounts, quite a rubbish rule, but it's the only process that works. Okay, so it looks quite messy, but okay, so 3x squared plus 5x, and we'll do that divided by x squared minus 4. Okay, so CDT in the top, CDT on the bottom. Okay, remember we can't cancel anything out because there's pluses and minuses. Okay, so look at the top first. 3x squared plus 5x minus 2. So remember, the number that we are trying to multiply two numbers to get now becomes -6. Okay, it becomes -6 because there's a 3 here that we need to take into account. Okay, this 3 multiply with that, and that becomes the number, the target that we're trying to get to. Okay, so let's write that out. So we're trying to add two numbers together, and that stays the same, which is confusing in itself. Okay, so we're adding two numbers together to make this 5. But we're multiplying two numbers together to make -6. Okay, and that -6 comes from this 3 and this -2 multiplying together. Okay, so when there's a number in front of the x squared, we need to take that into account. Okay, so we're trying to make -6, so the numbers have to be positive and a negative, or a negative and a positive. Okay, factors of 6 are 1 and 6, 2 and 3. Okay, so we need to make +5, so +6 minus 1 would give us that. Okay, so multiply together, those two numbers will give us this, added together will give us that. Okay, so this is where the messy bit comes in. Okay, and I'm not expecting you to have remembered this. Okay, but go back over the course of the next week and just have a look at what we did in regards to factorization when there's a number in front of that x squared. Okay, and remember, looking at different resources will give you different methods for this. So we looked at the BBC bite size and we walked through that. We looked at dynamic notes, walked through that, and looked at what I did. Okay, it's just one of those processes that just looks horrible. Okay, so our process that we worked on is we create two brackets. Okay, in the first bracket we're going to have 3x. Okay, so whatever this term is here minus that square. Okay, we're going to put in 3x in there. Okay, then we're going to take the numbers that we selected and put them in that bracket. Okay, so it's -1 and +6. Okay, if this is not ringing a bell, don't worry. I've been teaching this for many years and still had to look over it this afternoon. All right. So we've got that expression, and then we're dividing that whole thing by 3. Okay, we're dividing that whole thing by the number in front of the x squared. Okay, this, going from this, there's no mathematical concept of why this works. Okay, it just does. You might not be able to see the steps, but if you go through this process, you'll get to the right answer. It's just very messy. Okay, so we've got that. So we're looking to simplify that and try and cancel out that 3 at the bottom. We can't simplify that first bracket. Okay, so there's no common factors, but we can simplify that second bracket by bringing out a 3. Okay, so this is just this expression with a common factor removed. Okay, so now we've got this multiple. Okay, that's all divided by 3. Okay, so now we've got this term. Okay, we can cancel out this number here and this number because that top line is a multiple. So that bracket is multiplied by 3, which is multiplied by that other bracket. Remember, when there's a multiplication on the top or the bottom, we can then use cancellation. Okay, so that 3 in the top line and 3 in the bottom line cancels out, and that's our simplified expression. Okay. So that's a simplified top line. Let's go to the bottom line and do CDT. The bottom is x squared minus 4. Okay, CDT, no common factor, it is a difference of 2 squares. Standard format, first term plus, no, second term minus second term. Okay. Put it all back together. So we take the top term that we've simplified down. Okay, and hopefully you see that we can cancel this bracket and this bracket. Okay. We can cancel those whole brackets. And we are left with a final expression like such. Okay. These are quite horrible. Okay. It's taken into account algebra and fractions. Okay. Okay, guys, any questions on that? Okay. Obviously, don't work for the rest of tonight. All right. Clear your head a wee bit. Come back to this at the weekend and have a really good go at it. Okay. Go back to the factorization that we did a couple of weeks ago. Okay, in October. Okay, look through that. Just get your head back into that sort of common factor, difference of 2 squares. What is a difference of 2 squares? What's a trinomial? Get back up to that and then try these ones again, okay, and simplify them down. Please go over so if you're not struggling, but if you want a wee reminder of fractions, how we work with fractions, okay, how we simplify fractions, okay, how we add them together, take them away, multiplying fractions, and dividing fractions, okay. We'll look at this as a group next Tuesday, okay, but if you have a wee look at it over the weekend, okay, remember you can go back to National 4 as well. never be worried about or think, oh my God, I'm behind, I need to go back to National 4. If you don't understand a concept, go back to its simplest place, like I did with all the 2 squared and all that. I do it all the time. Go back to its simplest form, remind yourself, and then go back up. Okay? Don't try keep going and going and going with a concept you don't understand. Okay? I don't know what I'm doing here. There we go. Okay, so if you go into that 4, should be plenty. So there's algebra there. So if you want to go through algebra, and then you've got fractions there. Okay, and that will walk you through where we need to be before we start our conversation. Okay, you'd be amazed, it's not that huge a jump. Okay, you might look at it because we're throwing a lot of letters and numbers and square things. Okay, but the step by step of it is not that big a jump. Okay, so please go back through that, cancelling fractions, put something in its simplest form, get your head back in that, and then we'll really jump at it on Tuesday. Okay, that's fantastic, guys. I really appreciate that. Any questions, please email me. Okay, that's what I'm here for. So if you've got anything, even the simplest, if you've struggled with it for 10-20 minutes, give me a wee shout, take a wee screenshot and send it across. I'll happily come back to you. Okay, appreciate that, and I'll see you next Tuesday.
Thank you.
Thank you.